Okay, hey, training plants every day. Jordan Scoville coming at you from the STEM lab this morning. Now, I want to continue off of my conversation or my videos yesterday about mathematics or parapsychology, quantum mechanics is a lot like magic. Specifically, that card flourish. And flourish, I believe to be the right word. It's one of the best words I've found that describes what this really looks like. Not necessarily because it's all fancy, but because of the mechanical process in terms of how many different sequences and how many repeating sequences that could make a given trick for you. In psychology, we call this the marshmallow experiment, essentially. Now, again, there's a lot of things that it's called, and there's a lot of mathematical examples of spectrums and the laws of motion and quantum gravity based to force or frames of motion or moment 1, 2 over that radiant in a squared dimension, a stacking, platforming kind of aspect of a thing. Great. So, and again, I kind of break you down. Just let me show you real quickly in case you're not with me what I'm talking about here. This is a great way to start multiple different flourishes in whatever form you want to break them down. Let me see if I can do this correctly here. And the idea is you can create a lot of different frame states for this. And specifically, what I'm going to go with this as well in terms of the general's command directive is as you build this, you have to remember which techniques you're going to use and which patterns you're going to variant for this. So you can, so that way you can figure out what flourish pattern you want to do. There's all kinds of different singular aspects. That would be somebody's example of what their flourish pattern is, or a starting move. You know, again, from here, there's only so many limitations to what you can do with it. Now, again, there's different versions, how you're holding it. You know, this is quantum gravity and its aspect to define what north is, or a pattern. Now, that's going to be really important later. Okay. And the mathematics will support this. From here, there's multiple spectrums of different named trick patterns that can be created, whether it be that Z pattern, or you're just going to do a slide break with a secondary slide break, or you're going to rotate those around and do whatever. Okay. Each of those are somebody's given trick. And you could take a whole combination of those tricks, and you could time them differently. You can, from a given point, stack a system into there to make it your very, very own. Or get fundamentally good if you like that flourish. Get really good with it. And again, this is going to be that Warshak example. You know, Warshak, again, you know, it's not very sensible in terms of what it does unless you're just looking for that broad spectrum of somebody. Yeah, it's a butterfly. You know, and it can be really anything. But there's demeanors and personalities that can be immediately causally referenced from a given state, just like a marshmallow experiment. Somebody's going to sit there and wait for better marshmallows. You could say that they have more self-control. You could say that they have, you know, it gets weird when you deal with kids and stuff like that. However, there's a lot that goes into that, and psychology is, remember, analyzation over somebody's personal function, that when they give it a specific name, they're looking for specific categories of a thing, even though all events can be referenced by the experiment. Anybody can take that experiment. There might be smaller subcategories of your real personality. You might have great self-control, but right at that moment, you were hungry. So you wanted to eat that marshmallow now, instead of getting two later. I can't really dictate that for you, but some of the things in your demeanor and your personality are going to make that conversation more in depth later, because we do more than just one experiment here. You know, there's question controls, there's just like all the same stuff by physics of a different name, essentially. To name that rock, different experiments. You are a rock, essentially, in quantum gravity by this term. Nothing special about you at all. I can analyze you just like I analyze the wall. It's a little different when you get into people, though, because they have a lot of special makeup in their function that makes their elemental makeup when I go to determine exactly what that is in direct physics just a little bit different than saying that rock right there. But in the reality, every rock has a different mass, has different numbers of total makeup particles, has a different composition because of that, even though they're almost identical, two steel ball bearings. And they are just, at the quantum gravity level, just a little bit different. And even when you drop them or put them in water, at the most fundamental level, if you're aware of it and you can do more than just generalize it, they are just this much different. At the decimal level, at the fractal level, beyond 1 gram, right? Okay. So what I want to talk about today was how we talk about this in terms of a general command directive, what that does. All right. Firstly, we know a lot of these states. When you make up something like this in terms of a shot caller's book or a general command directive or a general S.T.E.M dictionary or resume, you have a lot of frame states in mind. So it doesn't matter which way down the rabbit hole you go about it, it all can link mathematically. There's a mathematical series or pattern or angles and what have you, and that flourish, that 5-minute conversation of you talking about making your apt abilities in this mathematics survive or psychology survive as much as the psychological principles that may follow directly. But one of the important things about this is that for the most part we're assuming that who we use it against is either the top level expert, and we're trying to get that vindication of, hey, we think the same way. When we look at both those rocks, a person and a rock, we can use this aspect of it, and it's going to be the same thing. It's going to be it in a different form. Again, remember that flourish pattern makes you a better chemist when I'm talking about that rock. It also makes you a better physicist or a psychologist or whatever variable on that, a general I use specifically. Why? Because when you're a general, sometimes it's not always best to know that somebody has a very high level of intelligence. Look at military. And I don't mean that to disrespect any of the higher troops in this function, but let's face it, it's sometimes better. We do things here at this frame level to function everything else, so they don't have to have all that free thinking in between a function, right? You know, it's just, I want you to know these given frames, and that's why I chose you for this mission. Everything else should be generally worked out, at least inside the hub. You know, when we get outside, there's a lot of reality, that mission, this function, you know, that hillside, this waterfall. Well, you're going to have to do some general free thinking, but we talk about all those aspects into that function. So when we compound it down to what is left, it's just general, that it's the name of this frame and the name of that frame. And how well you can combine, you know, what I'm supposed to do here against that waterfall and this function is going to make you function them a lot better. So the fact that you know a million billion different frame states isn't always the best thing when you're doing that. And I say the same thing here, because the point here is to teach you some general framing skills, some general forces, some general models that, like psychology or physics, is going to teach you. Analyzation, it's going to teach you noting skills, it's going to teach you inventory, it's going to teach you all of those things later, where you're going to need to be very specific about those skills later on. So even though I start with the mathematics, again, for me, it's just mathematics is the base for everything. You know, it's just the tool we use to do it. Is that the reality? Absolutely not. We start in physics, we start in the reality of a conversation, and then we break that down with numbers. So it's more than just those two things. It's a third part, or the fourth space-time problem that would relate to numbers, time, distances, numbers, masses, anything that would apply to that conversation. But again, those masses can be particles that make up a given frame. The A's, the ones, the notes, the bank of terms, how you head it, how that heading in terms of the mathematical aspect that forms those words, that first word that determined what that Big Bang was, generalizes it well enough so I can go back to mathematics. I can analyze it in the future from here to whatever real dimensions it is. There really is no extra dimensions. There's extra calculations, there's extra points, but beyond what we understand to be 3 dimensions, that's really it. We're saying time is the 4th dimension. It's a space-time, where and when. That goes back to those first 2 points. And the combination of those things, one way or the other, will give you 3 states, which is 1 state, which is a 5th dimensional calculation, which is a lot of different variables into what you're dealing with. And again, a further analyzation. How do I break it down into more parts so I can put that wave function under enough pressure, or high enough energy functions. I'm observing it from every angle. I'm calling it a bunch of different things so new particles can pop out. You know, when I'm in a stone dock or something like that, I use this particle to create new particles. You know, I'll put this against it and I'll push it as hard as I can in that function to see a new form of psychology. You know, when I'm a manager, again, when we talk about as a general, I don't need you to know all these states. I assume that you really don't. And when I put enough pressure onto that, I see a new experiment created. That when somebody starts talking to me in a form, that they have enough given mass in that aspect to reference themselves as understanding this function. Their understanding is, again, another term that has a definition that is only relative to what they understand in this function. So again, in certain ways, I do cheat this system. I bend it, I break it, I make it obey to my will. But that's the nature of a string theory and a wave function. It bends, you know, it breaks the standard aspect of what a particle does. It cheats, it goes through walls, and it'll pass right through functions and talk about gravity and how, you know, this aspect in a stone dock or a magic trick can go from, well, it's just a magic trick, to managerial skills, to inventory bases, to whatever function you guys want to use. You can talk about it. Say a word right now. Sure, great, love it, perfect, it'll fit. And it absolutely can. Just because I have a higher base skill in some of the more forms, all I have to do is add one thing. You know, you guys are going to have to calculate inventory and managerial skills and references and all that other good stuff. Resumes, applications. Application is a particle or piece of something, you know. How I can add something to it and it changes the quantum gravity of a thing. Okay. Another important notation about a lot of this is how we apply Newtonian order as quantum gravity. Okay. When I decide the function on whether it be this, it's very hard to write out. I use a landscaper's map, but there's no difference in determining what the landscaper's map is here. Why? Because as I'm breaking this down, I'm changing the topography, the topology. And one of my best experiments for that I've seen is you got a rectangle, right? And you cut it in one part into 2 sections and one into 3. And you have to pretend you're a ghost and travel all the way through this. There's a problem with that. It can't be done. Just topology, we give it a specific form. And now the topology of what quantum gravity is going to apply specifically here. So let's look at that here. You know, now it's changed. Now it's changed. And every time you do that, we're still looking at one string to pass this through. Now it's not impossible, not in this form anyways, because what we do with the end result flourish, this conversation, is that specific straight line. Except for the walls we pass through here aren't these frames. They're more like these frames. Ah, cool. Storm cauldron. Nice. They pass so seamlessly. You know, that steam cauldron is, or storm cauldron, it's brainstorming. It's all those frames that apply to a specific model in their very specific form. Okay. And in that landscaper's map, if we don't understand that example, we're going to have a lot of diversified inconsistency. Sometimes it's necessary to pass through the same space twice. You know, and the topology homework that you get for that equation, it's a rule that you don't do that. It takes up a little time. So, you know, when I'm doing this kind of flourish, once I set that back up and I close it all back down, and I want to set up another one, I might start with the same pattern. I might do a different pattern that has the same effect, that would look like a certain thing and passes through those walls again, but in a different space and time, which makes it completely different. But the Newtonian order of what that is says to make it that cool experiment that I tried and I've done a million times, I'm going to have to follow the Newtonian north. Catch you on the next one.